All right. Good morning, everyone. Uh, Today we will be discussing about virtualization, and then this is our agenda. So we're going to touch base on basic of virtualization. We talk about hypervisors, and then we talk about network virtualization, network, uh, network virtualization, and then I'll use some use cases. So So let's move on. Any definition I give about virtualization where it's not meant to be memorized. We just need to understand the concept. Why I always say don't memorize, there's more than enough to memorize. There's a difference between somebody memorize something and then he or she understands it, because it's like somebody say, what is biology? It can be defined in different variants, and then they'll see boils down to the same meaning. So the same thing applies to all the computer concept that we'll be talking. So we don't need to, that's why I'll be using some analogies and then simple definitions to drive home the point. And then at every point in time, if I'm too fast or somebody is not understanding what I'm saying, they should call my attention to that so that I will quickly do small justice to that. So, as the word implies, virtualization is a process to utilize physical computer hardware to create more resources or to create a virtualized environment. It's a process to utilize physical computer hardware resources to create virtualized resources or virtualized environment. What do I mean by that? In the beginning, I explained that computer has different components. That is why if we means the first session, maybe we should go back and listen to it again, because that's where we define the basic of computer. So moving forward, those are the basic we'll be building upon. So this visualization, we will get it clearly if we understand the basic of computer. What does that mean? Every computer has some basic composition or basic components. I will use the diagram to depict that. So let's assume this is our laptop. This diagram will be representing our laptop. Every laptop or every computer has similar components. That is when we were mentioning motherboard in the beginning. I mentioned this word motherboard. This motherboard presents in everything called computer. Everything that is called computer, this motherboard is there. So on this motherboard, there are some components attached to it. The other time I mentioned NIC. That is network interface card. I mentioned RAM, random access memory. And then I mentioned CPU, central processing unit. Central processing unit. And then every computer only have a storage. Every computer always have a storage capacity. So that storage can be HDD or SSD. We have touched base on all this before. So now, based on our conversation today, on visualization, this underground components will facilitate, that's what will give us facilitation of creating more resources on it. So now we have storage, central unit, RAM, and NIC on this computer. Let's use this one. Let's say we have U, R, and NIC. This is our computer, for example. Now, on this computer, there's what we call OS. That's operation system. This operation system, by default, once you buy any computer, it will come with it. It will come with it. So I don't want to use this method of reading or reading literatures. I want us to understand it in a very practical way. So now, this operation system, there's another component, is a software called hypervisor. Hypervisor. This hypervisor, it is not our duty to buy it or to install it. It will come by default from the manufacturers. It is coming by default. There are some other technologies that have come out latest in high-end servers that have come out recently. They have different hypervisors. That's what they call hypertrend. We'll talk based, if I remember, I will touch base on that towards the end. So with this is the foundation of visualization. Before the visualization can take place, what will come first is the physical device. What will come first is physical device. Because nothing can come from nothing. So we have our computer already that comes with all the necessary resources we need. That is, it has the central processing unit, it has the RAM, it has NIC, and it has storage, and then it comes with OS. On top of the OS, there is hypervisor. This hypervisor is the one that will facilitate our visualization. So if you will look at it very well, the visualization is a techniques to logically define or dividing computer resources. It is a logical way of dividing computer resources. But before we can divide computer resources, we must have a physical hardware. A physical resources must be there. So what it means is this. Every time we install, we are going to do that either today or tomorrow. We're going to start today, but tomorrow we're going to finish that where we start installing some of the components in our laptops. So every time we install an application on our system, it is now our duty to be thinking about operation system, hypervisor, and the other. Everything is already in the system. Our own job is to define our need. I want us to understand that basic conversation first, that every laptop, maybe a server, a client, they all have this from 1, 2, 3. They all have it by default. It is not our duty to program it or wherever. So the next step we need to talk is hypervisor itself. Once we understand that the computer comes by default with all these underlaid resources, but this on the third layer which will facilitate the spinning of instances or spinning of VMs, is called hypervisor. And the hypervisors comes in different variants. It comes in different variants. It has two types, major two types. If you look at it, this diagram is the same thing I was drawing before. This is the storage. This is the compute power. That is the CPU. This is the memory. This is the network. This network is the NIC. That's where the network address interface is attached to. So we have two types of hypervisor. And then we shouldn't forget, hypervisor is not an hardware. CPU is not an hardware. It's the central processing unit is not what we can see. It's a component that is attached to the motherboard, and then inside the component, there are some underlying or other component attached together that's making that functionality to work correctly. It is not physical to end users. So if you look at this diagram, we see that we have 1, 2, 3, 4 components. This is just the one they can mention. There are some other components, but these are the 4 major parts. At the middle here is the operation system. This is the hypervisor. And if you look at the hypervisor, on top of the hypervisor, we have the other machines. These machines are called virtual machines or virtual instances. So the hypervisor itself, it is a software. Like I said before, it is not a physical hardware. It is software on top of the operation system. So what are the types of hypervisor? I will use my server because I have the two types in my environment here. I have the type 1, I have the type 2. We just need to pay close attention to what we'll be doing now so that we can get the whole picture. So the type 1 is called bare metal. The bare metal is like when we go to the market, there's a procurement from the organization to set up a server, and we buy HP server. This HP server will come with 3 things. From the left, we will see that we have 1, 2, 3. This server is a brand new server from HP. For example, I'm giving this as an example. And they want to utilize type 1 hypervisor, for example. This server will come with storage. It will come with compute, that is CPU. It will come with memory, because that's one of the decisions we must have made before we purchase the particular server. Like when we want to buy iPhone, for example, or any other mobile phone, they always been sold based on capacity, the memory size, and then the storage size and all that. So the same thing applies to the other servers or other network components. So we look at that. So the server, that HP server, will come with the storage, the compute power, the memory, and then there will be interfaces. This server will not come with one interface like our computer does. It may have like 6 or 8 interfaces. But in this scenario, what we'll be missing is it will not come with any operation system. That's why they call it bare metal. That is why it's called bare metal. That is It's just bare. There's nothing inside. It will not come with operation system. That is type 1. Type 2 is, the example I can give for type 2 is our laptops. Because we're going to install our labs on our laptops. So this type 2, the second scenario is step 2, which it runs on the existing operation system. That's the definition. That is the first one I mentioned before. On this side, this picture represents type 2 hypervisor. This picture or this diagram represents type 2 hypervisor, because when we buy a new laptop, anytime we buy a new laptop, it will come with all this, apart from some of these images we see. It will come with underlying resources. It will come with operation system. We may decide our operation system. We may decide to buy Windows if we would like. We may decide to go with Mac. That is operation system, the Mac OS. We may decide to go with Linux. The hypervisor will come with them by default. Sometimes it is enabled. Sometimes it is our job to enable it. I hope it's clear. So the type 1 is bare metal. The type 2 is the application is installed on the existing operation system. We shouldn't forget that I mentioned that the first type, the bare metal, doesn't have operation system. The second one does. And then let me quickly mention this. This virtualization is the background for cloud computing. This virtualization is the background for cloud computing. How does that happen? Most of the cloud providers, they call them hyperscalers. What they do, they look for a large environment that has vast land. They build something like a warehouse. And then in this warehouse, they install this warehouse with a lot of equipment, like a lot of high-end servers that can withstand, that are very rugged servers that can withstand a lot of capacities. They call them data centers. These data centers, it will be remote to us. It will be in a remote location. So what they do is they now give this one out as what? As service. As service. Everything, every network IT resources we need, the cloud computers, cloud computer providers, they give anything we need from here to customers or consumers as what? As service. Because most of the servers here, they've been virtualized. They are physical server like what I mentioned before, but they have virtualization capacity. That's the basic of cloud computing. We'll still talk about cloud computing as we move forward. But I just want to know that the cloud computing itself is start from virtualization. We say we have two types of virtualization. We have VM and we have containers. But we'll talk about that one later. So that is the hypervisor side. Any question related to that, or if you want me to rephrase or to go more deep on it, any question?
Yes,
I've
but
mentioned the
I have a question.
visualization, the hypervisor, the bare meter, and then the type 2, which is the application. Hello?
Yes, Ahmed.
Hello?
Yes, this is Sharif.
Say that again?
Yes, I have a question
Okay, go ahead.
concerning the two types of virtualization you mentioned.
Okay.
You said the first one is a bare metal, right? And it
Yeah.
doesn't come with the
No,
operations.
it's
It doesn't.
not type of visualization I mentioned. I
Uh,
mentioned types of
Hypervisor, sorry.
hypervisor.
Okay. Okay. I think that's where my confusion lies. Okay, the type of hypervisor, you said one comes um with the operation system, right? And the other one doesn't have the operation system on it.
Yeah, the first one, the type 1 is bare metal. It doesn't come with operation system. It is empty, but it will come with the first layer, which is all the resources will come with it, all this one. But it will not come with these two. So it is our job to install any type of stuff we want on it. So the second one is type 2, which will come with everything here. What we need to do is just to pay attention to underlay capacity. For example, now, if I have 16 gig RAM of capacity, and I install a VM that has 32 gig RAM capacity to boot. Would this RAM come up? The answer is no, because the underlay capacity, that's the physical capacity, we shared from resources it has to this software to boot or to run. So if I want to run a VM that has 32 gig RAM capacity to run, that means I must have the physical server that has over 64 gig RAM, 64 gig RAM or more to run perfectly, because the resources will be logically shared to the VM to come up. That is the logic behind it. So let's move forward. Thank you for your question. So we understand the type 1, and then we understand the type 2. The same thing I mentioned here. So the type 1 hypervisor are installed directly on the hardware. The type 1 are installed directly on the hardware. And then the type 2, it will be what? It will only rely on host operation system. That is why the host operation system will be called hosted server. Hosted server. Why the VM that we install on the hosted server will be called guest operation system. We shouldn't forget that hosted server and guest operation system. It means it's like we as if anytime somebody visited us, we are the host, and then the person that visitor become a guest. The same logic they use in visualization. So the VM is the guest, which can be removed, deleted anytime. The host still remain the same. So I believe that one's clear. So all these are just literature. So all this type of visualization, we have data visualization, desktop visualization. For some of us who are not working now, there's what they call VDI. This VDI is very common now. Virtual desktop infrastructure. Anytime we are working with MSP, managed service provider. they use more of VDI to connect to their client resources. This VDI is a very tiny application to remotely connect to a network. So that is that. Some of us have used it. I've used it several times. Most of the guys that work from India, this is what they use majorly because they cannot send everybody laptop. So they configure VDI for them. It's like RDP client, but it's lighter than RDP. So I will touch base on some of those small things as we move forward. So we have desktop visualization, we have server, we have operation visualization, and then we have network. This is where we will be talking more majorly on network function visualization. This one, that's where we have VMs. That's where we have containers and all that. So we just need to know some of these concepts. We don't need to memorize anything. We just need to know, there are so many visualization types, and then they exist. We just need to know them. So based on that fact, on the benefits, it is very understandable. It is very easy to understand the benefits of visualization. The concept is this. Anytime we need an application to run in our environment, our application guys, they want to deploy applications, new application in our environment, in an enterprise environment. Before, the traditional way is we will need a physical server to be procured. Maybe we have one before, and then now this one is running another application, this one is running another application. So we want to do another application. Maybe we are running on e-commerce. Then we want to deploy a new application. So anytime we want to deploy application, we need to buy another server. This is third one. And then sometimes we may not utilize those resources effectively because they are physical servers, they are there, sometimes they are redundant. They will just sit down in the rack doing minimal job. So, so they will be, they are not doing minimal job. But with the advent of visualization, it reduced the cost. That is one of the benefits of visualization is it reduces cost. It saves maintenance cost. It reduces overhead cost. Because instead of buying the third server or having 3 servers, we can install VMs on this number 1 or number 2 server or number 1, as case may be. We install VM there and we run our application on each VMs as we may want. And then immediately we run our applications. If there's no need for it, maybe it's just POC, it's just POC, we may decide to delete it or remove it because each of the VMs will be treated as a file. When we go to the lab now, we will see some of those VMs, but I just want to paint background picture that is the technology between every visualization. It is the underlay physical resources. It's not a magic. They are built upon a physical resources, whether on-prem or in the cloud. So I've mentioned virtual machine for more than 3 or 4 times now. Some of us don't know what is virtual machine. Virtual machine is a machine created by hypervisor. And then we know the type of hypervisor we have before. We have type 1, we have type 2. And then each of the virtual machine will be treated as a single file. it should be treated as a single file. So anytime we deleted the file, that's why some of us who have the lab before, anytime maybe we just mistakenly delete a file in our system, the virtual machine will not come up again. They are very tiny application. That's a VM, virtual machine. It's a virtual machine. That means it's an abstraction. It's not physical. The only physical we can see is the laptop in front of us that we use to do the visualization. So that is that. So let me show us type 1, and then we'll talk about type 2 quickly. Okay, let me go to my lab. I have a server that I install my VM on. It is type 1 hypervisor. There is a 10.0.0.4.0. So this is my server. This is an example of hypervisor. I will say touch base a little bit about the major vendors. This is one of the major vendors in hypervisor, VMware. They specialize in virtualization. So when I buy this server, this is my server, I install this there. This is the operation system now. I made the decision of what I want on the server. This is what they call type 1 hypervisor. So I will log into it. Let me log into it quickly. Root. And then I remember the password. All right. This is the type 1 hypervisor, for example. This is where I install my VM on top of this server. If you look at it, we see VMware ESSI. Some organizations are using it the way I'm using it. But what will be different is the memory capacity. If we look at the left-hand side, we see what they write hardware. This is hardware. And then the manufacturer is what? HP. This is just the model. This is the CPU. This is the memory. Those resources I mentioned, and they come with the underlay physical device. The only thing I installed there is the VMware ESSI. Some of us who have worked in big enterprise, we notice that sometimes when we want to deploy like on-prem VM for like firewall or for like switch, switch. We want to deploy like F5. We can deploy them here in this environment. So anything we deploy here will now become type 2. Anything we deploy here will now become type 2 hypervisor, because the first one I installed, this VMware ESI, will give me type 2 facility. That is, the hypervisor will be here now, operation system will be here, so I can now make decision on what to deploy. If you look on the left-hand side, I have my EVNG here. This is my EVNG. From the EVNG, we can see some of all these resources allocated to my EVNG. Look at it, it has its own hardware. And then we see that we have vCPU, that is Virtual Central Processing Unit. It will allocate everything that we allocated to the virtual machine will be called vStuff. It can be vSwitch, vRAM, vCPU, because it's being allocated to it based on the fact that the system is installed here, anytime I remove this EVNG, this my VM from this server, all these resources will be reallocated back to the server. I hope that part is clear. Because I don't want us to be reading literature alone. We need to follow up with the good examples of what we're talking about. The first time I was taught about hypervisors, was blurred to me. It wasn't clear. So when we start installing our when we start installing lab on our system, we should remember that we'll be working with type 2 hypervisor. Type 2 hypervisor, and then what we'll be installing there is virtual machine. And then the virtual machine is created by who? By the hypervisor. So this is another good example. On this example, we see that this is a physical device. This is a laptop or a PC. From this PC, we have virtual hardware. We have guest operation system. We install application. Everything still boils down to what? To hypervisor. So we have hardware from the hardware CPU, from the hardware memory, from the hardware NIC, and then from hardware disk. That is where we allocate all the resources to the virtual machine. If we look at the diagram, we see that it is on top of the device. It is not in. It's showing that it is a guest. It's not the hosted operation system. So that is what that is depicting. All right. So all this one, we just need to know it for knowing sake. But the important thing is to understand the type of advisors, how they work, and how we can make use of it. All these are just literature. So here I just mentioned some of the vendors. We need to get familiar a little bit with some of the vendors of certain products in the industry. For example, this type 1 hypervisor, if you will look at the example I gave before, I said I have the server. This is the hypervisor I use. This is the one I use now. VMware ESSi. This is the one I'm using. I have an HP server I bought, and I installed this bare metal hypervisor on it. VMware is one of the major players in the market of virtualization. Even some of the biggest cloud providers, they are their customers. So VMware has ESSi, Microsoft have Microsoft Hyper-V, and the Red Hat, Oracle, others are the literature. So type 2, this is where we're going to work for our lab. Type 2 hypervisors. If you look at the type 1, we have some players there. In type 2, we still have the same player. Look at type 1, we have VMware. They are in type 1, they are in type 2. Oracle, they are in type 1, they are in type 2. That means the players can be heterogeneous. So what we need to understand is some of these vendors, they have different product line. One of the product line of Oracle is VirtualBox. Another one is VM, they have virtual machine, they have a virtual workstation or virtual workstation player. This is what we'll be using to set up our lab. We're going to download it, we'll install it, and then we're going to install a virtual machine on it to set up our lab. And then I mentioned some like VDI before. This is the VDI virtualization vendors. The major player is Citrix. Citrix they are very good in doing stable VDI. They have other products, but their largest market share comes from VDI. So other ones, other players, they have their other things. We can read a little bit about it. And I've mentioned cloud computing before. Cloud computing, it is self-service of IT resources. That is on-demand self-service IT resources. Most of the major players are this: Amazon, Microsoft, Google, IBM, and some other players. This is not exclusive list. This is just part of the players. So, and then all this one, they're just concepts, they are just literatures. But the important thing we need to remember is, before we can do visualization, what are the things that are necessary, the type of visualization we are using, and then how it's being used. It's not a magic, it is combination of components that is giving the end users or the consumers the value for their money. Because a lot of people have heard about cloud computing, they don't know the technology behind it. So that's why I say, okay, let's go behind this. Let's go and let's analyze this one today. So when we are deploying our lab, somebody will not be confused the lab environment to working environment. So our lab environment will be a simulation environment where we'll be simulating what is doable in the enterprise environment. We'll be simulating what is applicable or configurable in a working environment. For example, now, if you buy a toy car for a kid, the toy car may come with all the facility of a real car. So if we now see a real car, it will not be a mirage. It will not be a surprise. So it will serve an example. So some of the people that fly aeroplane today, they use simulation aeroplane to fly aeroplane. They don't just start with the real one. So the same way, we're going to start with a lab to simulate environment or to simulate an enterprise environment moving forward. So that is that for now. Any question or any suggestion? That's where I'm going to stop. I've touched base on some of the use cases, and then the summary of it is virtualization is the way of logically utilizing a server or computer resources to spin up another set of application or VMs. So it is not a definition that we need to memorize. We just need to know that virtualization means virtual. It is not physical. We have, like now, I show us vCPU. That vCPU comes from the physical server, which is sitting down very close to me in my house here. So anytime we are hearing cloud computing, it's a physical server stored somewhere, located somewhere, that consumers can access it based on demand, because part of the needs definition of cloud computing, that it must be it must be on demand, it must have a lot of pool resources, and then it must be on billing, or it must be on billing purposes. So that is that for now. So tomorrow, by God's grace, we will deep dive on setting up our lab, and then the next one will be subnetting, because now we have about 4 or 5 clients to go to hand the networking part before we jump into firewall, and then we started testing the ground. Nobody will ask us what's evaluation in an interview. No, but it is implied knowledge. It is assumed that this person should know this. So that is that. Any question? So somebody's raising hand. Let me see. Okay, I see Mr. Barry raising hand. What's the question?
Yeah, I've been raising my hand since, but I just don't want to interrupt you.
Okay. I see the hand now.
Yeah, so my first question is all the component that you mentioned earlier,
Yes,
everything
sir.
is sitting on the motherboard, right?
Yep.
Including the virtual what is it called? I want to remember the name again. The hypervisor.
No.
Hello? The hypervisor is not on the motherboard, right?
The hypervisor is a computer. It's a software. It's a software.
Okay.
If you will remember that I mentioned that when we are installing bare metal, it will not come with hypervisor. The bare metal will just come ordinary. They will come with a set of the first layer, the storage, the compute, the memory, and the network. But it is environment that it will enable, when I install VMware ESSi, it is enabling environment already that HP has designed. That is, anytime we install VMware ESSi, the hypervisor should be triggered because the ESSi will come with everything I needed.
Okay, my question is, where is the hypervisor sitting? Is it sitting in
It
the
is a
server?
software.
Okay.
It is software
But
that will.
software do software sit on something?
Okay. How will I explain it better now? Okay, let's go this way. Let's assume we buy a new laptop. This laptop, it has a motherboard. Let's assume this is a motherboard, right? This motherboard has SSD. That's the storage. It has CPU. That is the processing power. It has a RAM. That is memory. It has a network. That is the NIC. Fine. Okay. The next thing that will follow the laptop is operation system, OS. It could be Windows or Linux. Is it clear now?
Yeah.
This is a brand new laptop. This is a brand new server. Now, on top of this operation system, it will be default come with the hypervisor. It will sit on top of the OS.
Okay.
So by default, this laptop is ready to be utilized for whatever we want to use it for. Some people are using their laptop for just to browse, just to connect to some stuff. But if we need to install some high-level applications, like now, we want to set up our lab on a brand new laptop. It is presumed that everything we needed is there. The hypervisor is there already. And there is, on this type of categorization, this is type 2, for example. This is type 2 because it has what? It has operation system already.
Operations. Yeah.
I gave an example of my server. It doesn't have operation system, it doesn't have anything. What it comes with is just, I bought it because I look at the server, I see the memory, I see the hardware, and I see it has some interfaces. It has some other features that we don't necessarily talk about here because we're talking about visualization. So now I made a decision of what I want to install on it because it doesn't come with operation system. So With that, they define that class of setup as type 1 hypervisor. Or they call it bare metal. So we don't, as we move forward, we will understand it better, because most of the thing we do in the industry, when we start testing it on our own or we're deploying it, that's when it's going to make more sense to us. It may not make more sense now, but when we start utilizing it, it will paint more pictures. So any other question? So tomorrow we're going to set up the lab and then we move forward from there.
So tomorrow are we using our, okay, so I'll be using my cell phone for this class. So tomorrow just use a laptop because of the lab, correct?
It's your choice, because my own job is to demonstrate as done, and I will point out some of the application needed to deploy, to download. So if you feel like you want to do it tomorrow, fine. If you feel like, oh, we watch the video later and walk myself through, anything works.
Okay. All right, sounds good. Thank you.
Thank you. And then why I emphasize on cloud computing a little bit is that is the trend now. That's the way the industry is going to. And then if we don't understand the basic of virtualization, and then we jump into cloud computing, it will be like magic. No, it's not a magic. There are high-end or cutting-edge devices situated somewhere that is they are now giving us as a service. It's like the cloud computing example. The good example is when we okay, maybe we get our own house or our own business. We decide to buy a generator to power the company. This is the journey. Everything will be supplied by us. That is the fuel, the maintenance, the replacement, and then we need to have standby engineer that will be managing, or that will make sure that our generator is up and running, because anytime this generator is done, it will impact the flow of business. The opposite scenario is if we would feel that, oh, we have environment where we have a stable company that can provide the same service to us without buying fuel, without having an engineer to be on standby, without needing of replacement of parts. Somebody say, okay, a company like Georgia Power or some other company say, oh, we're going to provide you service. We bring light to your house or to your business uninterrupted, but you'll be paying on subscription. You'll be paying on subscriptions. These same subscriptions will be paying to any service like Georgia Power or internet service. That same subscription we pay to cloud providers, or we call them hyperscalers. So we pay them because they have already installed the server in their own premises, in their own locations, that has high-end or cutting-edge technology that can facilitate, or that is tailored to our own need. Because what they render out or what they sell out is they sell out some of the resources we will have that will have cost of money to store on our own. They have server, they have switch, they have firewall, they have router, they have everything in their own environments. Our own just to subscribe to it. So when we finish firewall class, we will jump into basis of cloud computing, and then we need to open our own accounts so that we start testing how they go. Most of the time now, when we go to interview, they ask questions related to cloud computing. Nobody is a Superman in cloud computing now, but we just need to have basic knowledge about it. So that's just it. Any other question?
Quick question.
Okay.
So I would say hypervisor is the brain behind cloud computing or visualization based. Basically.
Visualization.
Yeah. Do you get what I said?
Yeah, I got you. I said visualization is the brain behind it.
Okay. So what's the role of hypervisor is the what's the role? Hypervisor is just the link between the system and the virtual and the cloud computing, right?
Okay, this is what we need to remember. We need to remember the visualization. The type of hypervisor is just to know the technology behind it. We don't even we may not even remember it again, but we need to know that there are types of hypervisors. If you want to do any exam now, they may ask that questions. But in the working environment, related to interview, hypervisor doesn't come to play. What comes to play is visualization.
Okay.
So we need to remember that a physical computer is logically divided to create another set of virtual machine. It is logically divided to create another set of virtual machine. On top of this virtual machine, we can install application there. Maybe for testing or for any other thing, maybe for consuming, because sometimes we deploy internal application for internal consumer consumption purposes. So what we need to remember majorly is the virtualization.
All right. Thank you.
Okay.
Mr. Abe, please, can you add me on the chat, the group chat, because I'm not on there yet.
Okay, I'll do that.
Please, so I can get the recording as well. Thank you very much, sir.
Okay. So
Okay.
do you have any question or any overview?
Me?
Yeah.
No, sir. The virtualization and the cloud computing is something that I'm really trying hard to get my head around. I will use the word is difficult for me, right? For lack of a better word, even though it's simple for you, sir, because you have been there longer than everybody else. But for me, the words are just a lot. It's just a lot for me, sir.
Okay, no problem. We're going to
with
break
this,
it down.
that is actually the reason why I joined this class. Is the cloud computing that really got me excited about it. So we will see as it goes. I think it's getting better, though. I believe so. All right, thank you.
No problem. All right. So this is what we call it a day for today. So tomorrow we're going to set up the lab and then from there we'll move on. So thank you, everyone.
All right. Thank you.
Thank you so much. Bye-bye for now.
Thank you very much.
Thank you.
No
Thank
problem.
you.
Thank you so much.
Thank you.
Thank you, sir.
Bye-bye.
Thank you.